Hi everyone. So welcome to Unacademy, India's largest learning platform. You can take the Plus subscription and access unlimited live and recorded courses from India's best educator. So this is about me. I am a computer science gate faculty, having more than teaching, having more than 5 plus of teaching experience, mentored more than. So just a minute. Yeah, good evening, Mansu. So this is about me. I am a computer science gate faculty, having more than 5 plus of teaching experience, mentored more than 15,000 students, taught in different coaching institute all over India, qualified gate multiple times. Okay, even I qualified gate multiple times. So the places where I've given the coaching is like even in government and private colleges I've given the coaching like SRM Chennai in Tamil Nadu, CET Bhubaneswar in Odisha, BCE Bhagalpur Bihar, Jorat Engineering College in Assam, Guwahati University in Assam, Dibrugarh University in Assam, Government College of Engineering and Technology Jammu, Ramgarh Engineering College Jharkhand. So there also I went. So today also I will have one TUC class that is going to be in Hindi. Okay, TUC in Hindi. It is going to be free online classes. So you can follow me in Unacademy because there also I am taking a free live classes. Okay, there also I am taking a free live classes. So you can follow me there. Okay, in the description my profile is given. You can follow me there. Okay. So we are having a two type of classes product in Unacademy. One is Plus subscription, another is Iconic subscription. In Plus, we are having India's best educator, interactive live classes, structure course and PDF, live test and quizzes. In Iconic, along with the benefits of Plus, that is India's best educator, interactive live classes, structure courses and PDF, live test and quizzes. We are having a personal coach, personalized test analysis, study planner, preparation, study material. Okay, we are having this also, and even we are having a special classes which is going to be, which is called as free live classes, which is called as free live class, which is called as free live class. Okay, so a special class is called as free live class. There you can watch free classes. Okay, and from first of December, to watch special classes you have to use the code. Okay, so you can use the code that is SPSYT to watch even the special classes. To watch the special classes, you should use the code SPSYT to watch it free. Okay. Now you can learn with top educator that you will get it on Academy. So if you take Get an ESC subscription, you are going to have batch and year long courses, ECE courses, general aptitude courses, chemical engineering, mechanical engineering, CSIT, instrumental, mathematical, electrical engineering, civil engineering, production and industrial. So all the courses you will have the access. All the courses you are going to have the access. So if you will take the Iconic subscription, the price of this Iconic subscription after applying the code SPSYT. So SPSYT is my code. So from 1st December towards the free live classes also you have to use the code. So you should use the code that is SPSYT. ऐसा क्यों स्पेशल क्लास के लिए भी कोड? I don't know Arpan. So this is the fee, means decision of the management. Okay, not me. So you have to use the code that is SPSYT. So you should use the code SPSYT, and even if you use the code, see why SPS, it's my name Suraj Shaw, YT for YouTube. So you will get 10% instant discount. If you use this code, you will get 10% instant discount, and the price for 1 year is going to be 45,225, and for 2 year you have to pay just 66,600. For 2 year you have to just pay 66,600. Now for Plus, for 1 month the price is going to be 4,950. 3 months is going to be your 12,375, and 6 month is going to be 22,275. Okay. Can I use your code to see any special class? Yes, Arpan. So you can use my code SPSYT to watch any of the special class. You can use the code SPSYT to watch any of the special class. Okay. So from 1st December it is going to be effective. To watch special classes also you have to use the code. So you should use the code SPSYT to watch any of the subscription, to watch any of the special class, or the uh, to take any of the subscription also. Okay. Now for 12 months the price is going to be 27,225. So all these prices are after 10% instant discount, and you can redeem the point also that you have credited after watching the videos. Okay, so if you'll watch the free classes there, you will get some point. Okay, so you can redeem there. So you will get more discount, then you will get more discount. Okay, so for 18 months you have to just pay 34,650, and for 24 months you have to pay just 39,600. 39,600. Now this we have seen in the previous lectures. Huffman coding we have seen. Huffman coding is also called as unequal size encoding, different size encoding. It is done by greedy method. Okay. So today we are going to see some of the example and previous year questions. So Huffman coding is used to, so this just I am giving a recap. So we use Huffman coding to compress a file, to compress a file, like window use in zip file. There they use Huffman coding. Okay, so there we are using prefix encoding is used in Huffman coding, because then unique encoding and decoding is possible. So what is prefix encoding? Prefix encoding, any code is not going to be the prefix of any other code. Okay, so 0 is not going to be the prefix of any other. If say here 0 is the prefix here, so it is not the prefix encoding. So we have constructed so many. We have seen the linear way, uniform way, and uniform way of encoding and non-uniform way of encoding. Then we have find out why non-uniform was important and how Huffman coding was useful. Okay, that we have seen. Step we have seen how to do. Okay, so are you, so anyone wants revision of that? Because after that I will start. Is it clear now to all of you? The code and all we have seen. Is anyone wants the revision of that, or can we start now? Yeah, good evening, Nisu. Fine. So now I'm going to take the questions. Now, Huffman coding can also be stated as, so the another way of asking Huffman coding. Don't get confused when in this way they are going to ask Huffman coding. Huffman coding can be stated. Another way of asking Huffman coding. Another way of asking. Ah, correct. Correct, Nisu. Another way of asking Huffman coding is how can you build a tree, how can you build a tree, so that you can you can you can decrease the, so that you can decrease the, so that you can decrease the, so that you can decrease the weight of, so that you can decrease the weight of the, weight of the external path length. Okay, another way of asking Huffman coding, how can you build a tree so that you can decrease the weight of external path length. तो weight of external path length हम कैसे decrease कर सकते हैं, इस तरीके से भी गेट एग्जाम में आपसे पूछ सकते हैं. ठीक है, तो आप वहां कंफ्यूज मत होइएगा. आपको पता है weight of external path length is going to you total. हाँ, 11 बजे रात को टीओसी की क्लास है नीसू. सो यू कैन बिल्ड ए एक्सटर्नल पाथ लेंथ. ठीक है, आप बिल्ड कर सकते हैं एक्सटर्नल पाथ लेंथ. So how can you reduce? So by using Huffman coding, we can reduce the external path length. What is external path length? Can anyone tell me? The total number of bits required to construct a tree is going to your weighted external path length. Weighted external path length. Okay. So now we will take some example. Another example. So let A is having, yeah, total number of bits. So character. Here I am giving you a character, and you try by yourself. Okay. A is having a 40 frequency, B is having a B is having a 30, C is having a 20, D is having a 5, E is having a 3, and F is having a 2, and F is having a 2. Okay. So how to construct? Now we will construct a tree. Okay, that by using Huffman coding we are going to. So you in a file you are having a six six characters. Sorry, six characters and the frequency. This is the frequency and characters. Okay. Now we will use Huffman coding to encode this. So first we are going to do. So we are having first node is 40. We are having first 40, 30, 25, 3, 2. So first I will take 2. 2 is going to a left hand side. So 2 is your if and then you are having E, that is going 3. Now combine these two, you are going to get 5. Okay. So deleted these two, you got 5. Okay. Now 5, 5, you are having now 40, 30, 25 in the tree. First you will create a queue. Okay. First you will create a queue. This is a queue. So I am not creating a queue, but you assume that it is a queue. And every time so you are going to delete the minimum here. Min. Okay. So now you are having two min is 5 and 5. 5 and 5. So you will take the list minimum. Okay. Two list. So 5 is already there and another 5 is your D. So you take D here, 5. Then you will combine these two, you will get 10. So now you are having these two deleted and new node added. You are having 10. Now 10 and 20 in the tree. 20 going to be in right side because always the smallest is going to be on the left side. So 20 is going to on the right side. So which is 20? C. So it's going to be 30. It's going to be 30. Okay. It's going to be 30, 30 and 40. Okay. Now you will take the two minimum 30, 30. Okay. 30, 30. Now see, here also when you are having 5, 5, you have taken the new node on the left hand side. So you should again take the whenever you are getting a same frequency. Here you are getting a 5. Here also you are getting a 5. So whenever you are getting a same frequency, you are taking the new node on the left hand side. So again, if you are getting a same frequency, you should take the new node on the left hand side. Again, you should take the new node on the left hand side. See, this way you have to follow. You have taken whenever same frequency is coming, you can take any node in the left and right side. But if you are taking on the left side, then again you should take on the left side. So 30 is your B. So 30 is your B, you should take on left hand side. Now it's going to be your 60. It's going to your 60. So these two deleted. So 40 and 60. Now you are getting 40 and 60. So 40 is going to a left hand side because it is having the less. So which is 40A. So you got a tree which is having a frequency of 100, which is having a frequency of 100. Okay, understood. Now on the left hand side you use 0 and right hand side you use 1. Okay, so you are going to get the code for A is going to your 0, B is going to your 1 0, C is going to your 1 1, D is going to your 1 1 0 0, 1 1 0 0, and E is going to your 1 1 1 1 0 0 1 1, and F is going to your 1 1 0 1 0. F is going to 1 1 0 1 0. Okay, this is the code you have got. So now you are going to find the weighted external path length, or that is going to be total bits required for the encoding. Now we are going to find weighted external weighted external path length, weighted external path length, that is going to your total number of bits, total number of bits required, that is going to your total number of bits required. So A frequency is having 40, so 40 into 1, then B 2 into 30, 2 into 30, then C is your 3 bit required, so 3 into 20, then D 4 bits required, 4 into 5, then E 5 bit required for E 3, then for A 5 bits required 2. Okay, that is going to into 2. So it's going to be 40 plus 60 plus 60 plus 20 plus 15 plus 10. So it is going to your 5 at the last, then 10, 16, 18, 90, 20. So 205 bits required. Weighted external path length is D. Now we need to find average number of bits per character. Okay, is it done? So you can like this session, okay, and you can subscribe this channel. So if it is done, then please let me know. You can comment D. Fine. Now we are going to see average number of bits, average number of bits per character, average number of bits per character. It is going to your weighted external path length by total number of character you are, total number of character. The total number of character will be at the root will show the total number of character. You are having 100 as the total number of character. So that is going to be total number of character. Total number of character. Okay. So weighted external path length is your, how much is your 205. Total number of character is 100. That is going to your 2.05 bit per character. Now give a note and write every time, every time Huffman code, every time Huffman code will be prefix code. Every time Huffman code will be prefix code, and the tree will ensure, and the tree will ensure that that prefix code will happen, and the tree is going to ensure that prefix code will happen. Why? Because every node is going to be at the, because every no every character, because every character is at the leaf, because every character is at the leaf, is at the leaf. So there is no chance to get same sequence with another. So there is no chance. So there is no chance to get. So there is no chance to get same sequence with other. So there is no chance to get same sequence with other. Okay. Every time Huckman code will be prefix code. Every time Huckman code is going to your prefix code, and the tree will ensure that prefix code will happen. And tree is going to ensure that prefix code will happen because every character is at leaf. Since every character is at leaf, so there is no chance to get the same sequence with other. So there is no chance that same sequence is going to be with other. Okay. Now I have a question. When to use sorting algorithm and when to use heap algorithm. So this is a question, when to use sorting algorithm, when to use heap algorithm. So here I am using heap, but I am not using sorting algorithm. Now tell me the reason. Here I am using a to find the minimum. We are using a heap. Okay. Why we are not using a sorting algorithm? Because yeah, correct, Bhaskar. Repeated movement, removal of mean or max element. There we can use heap. And even if here if we'll use sorting algorithm, then to find we are going then to insert a node, it is going to take big O of n time. Okay, big O of n time. So that's why here we are not going to use sorting algorithm. Okay, because to insert a node in a sorted tree in a node, if the list is sorted, then you are going to take big O of n time, and here you are going to insert n minus 1 times. N minus 1 times you are going to insert. Okay, नहीं तब n स्क्वायर हो जाएगा भास्कर. देखिए मैं क्या बोल रहा हूँ. देखिए क्यों n स्क्वायर हो जाएगा. देखिए ये दिस काइंड ऑफ क्वेश्चंस दे आस्क इन योर गेट. So they are asking you that in Huckman code you are using a heap. In Huckman code you are using a heap. In Huckman code you are using a heap. But if we'll use a sorted algorithm, some algorithm, now here always you are going to insert, you are always going to insert a node. Now if we'll insert a node, insertion is going to take n time in case of some sorted algorithm. In case of some sorted algorithm. Okay, so if we are using the some sorted algorithm, means compression based algorithm, okay, then it is going to take big of n. In a list, if it is a sorted, if you want to insert a node, then it is going to take big of n time, and n times you are going to insert, that will become big of n square. See, please let me know whether it is clear or not. So to insert a node in a sorted list, it is going to take time as big of n. It is going to take time big of n because you will find the position, then you will do the movement. In worst case, you have to move all the element. Okay, this I have shown you. So you have to do in to insert one element, it will take n big of n. Now to insert n element, it will take n into n, that is going to be big of n square. That is going to be big of n square. Is it clear? So that's why we don't use here sorting algorithm. Okay. So Bhaskar is saying clear. किसी को कोई डाउट हो तो पूछिएगा, ठीक है ना. आप हिंदी में भी पूछ सकते हैं, हिंदी में डाउट रहे हिंदी में क्लियर कर देंगे, ठीक है. सो यू राइट whenever we need whenever we need whenever we need to delete mean or max and insert the newly element and insert the newly element, then we must use heap. ओके. तो हमें heap ही यूज करना चाहिए. इन हुकमैन कोडिंग in Huckman, if we apply sorting algorithm, then insert will take big of n time, and for nearly n minus 1 times, and for nearly n minus 1 times, it will take big O of n square. So we need heap. So we need heap. Now, in case of knapsack, we were using only what we are using. We were using only a sorting algorithm, because there we it is not required to insert. Okay, so if we need only mean and mix and no insertion, then we can use the sorting algorithm. If we need only max or mean, no insertion, max or mean element, and no, not to insert, and no insertion in the data structure, no insertion into the data structure, then we should then we should use sorting algorithm. Then we should use sorting algorithm, like we were using in knapsack, Okay, so if we need only max or mean element, and no insertion into the data structure, then we should use sorting algorithm. As like in knapsack. Okay. See, if you're done with the writing, then you can let me know. Now we will go to Bhaskar is saying done, sir. Now we are going to see one gate question. Okay, one gate question we are going to see. Two more questions we are going to see. Okay, two more we are going to see. Now see there, it is asked in your gate 2002, gate 2007. It is asked in your gate 2007. They are asking that suppose the letters, A, B, C, D, E, F have have probability have probabilities 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32, 1 by 32. Okay, so suppose the letter A, B, C, D, E, F have probability this. Okay, means the number of times, the frequency of probability is this. Okay, so that in a file, the probability of A coming is 1 by 2, B coming is 1 by 4, C coming is 1 by 8, D coming is 1 by 16, like this. Okay, so now they are asking which of the following which of the following is the Huffman which of the following is the Huffman code which of the following is the Huffman code for the letter A, B, C, D, E, F. Now they are asking which of the following is the Huffman code for the letter A, B, C, D, E, F. Okay, now I'm giving the option. Okay, you can try 0 1 0 1 1 0 1 1 1 0 1 1 1 0 1 1 1 1 5 1. B is your 1 1 1 0 0 1 1 0 1 0 0 0 1 0 0 0. C is your 1 1 1 0 0 1 0 0 1 0 0 0 1 0 0 0. And D is your 1 1 0 1 0 0 0 1 0 0 0 and 0 0 1. Okay. So please comment when you are done with the writing. Okay. So now we will start, or if you want to try by yourself, you can comment. Otherwise, I will start solving. If you want that you want to solve, you can comment. Otherwise, I will start. Now see here. Here, suppose the letters A, B, C, D, F have the probability. A is having the probability 1 by 2, B is having 1 by 4, C is having 1 by 8. अच्छा भास्कर is saying 1 minute almost. Okay, ठीक है बताइएगा. C is having 1 by 8, D is having 1 by 16, E is having 1 by 32, F is having 1 by 32. Now they are asking which of the following is the Huffman code for the letter A, B, C, D, F. So I am writing the frequency. Okay, you can try. Just I am writing the frequencies. So for A, they have given. They are asking the Huffman code. Okay. So for A is 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32, 1 by 32. Okay. 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32, 1 by 32. Now if you want to convert, since let's wait for Bhaskar just for 1 minute. Other can also try. Correct, correct, Bhaskar, correct. Very good. So now continue. Now see here, since the probability is given in fraction, since probability is given in fraction, you can convert it into number. Okay. So since the probability, how we can convert? Since the probabilities are given in fraction. So it is given in fraction, and if if want to work on non-fraction, we can convert every probability every probability every probability with non-fraction non-fraction. We can convert every probability into non-fraction. Okay, how we can convert? We will take the LCM. Here see, LCM of all this is 32. You multiply with 32. You multiply into non-fraction. For that, we have to multiply. We have to multiply. We have to multiply with 32. If you multiply this with 32, 1 by 2 into 32, you are having 16. Means frequency of A is 16. Here is your, if you multiply it with 32, you are going to get how much? 5, 6, 7, 8. Okay. Then here 4, here 2, here 1, here. Now just add this all. So 8, 16, 24, 28, 29, 30, 31, 32. See, you are getting 32. If you are adding all this is going to be 32, means you have did it correctly. So this is the frequency. You have multiplied. You have multiplied all the probabilities with the 32. Okay. So now you will use the, you have to find the frequency now. You have to find the frequency. In fraction they have given. So you convert into non-fraction. First you convert it into non-fraction. So that's why you have multiplied with its LCM. With its LCM, if you multiply with its LCM, you will convert it into a number, non-fraction. Okay, non-fraction. Now construct a tree. You are getting E here 1 and F is 1. So E is 1 and F is 1. Okay. E is going to your 1 and F is going to your 1. You have added. So I need to take the is your having. So I require some more space. So I will writing here A, B, C, D, E, F. You got here A is your 16. Here is your 16, 8, 4, 2, 8, 4, 2, 1, 1. Okay, 8, 4, 2, 1, 1. So you will add these two. E will be here and F will be here. Here 1 and 1. Then you are going to get a node 2. Okay, so now 16, 8, 4, 2, 2. Okay, now you are getting two nodes which is having a list here 2 and 2. So I am writing D on left hand side. I am writing D on left hand side. I am writing D on left hand side. D on left hand side 2, 2, 2, 4, frequency 4. Now your again 4, 4 I am writing C. If whenever a node having same frequency is coming here 4 frequency here 4, so always new node I am placing on the left hand side, so always you have to place, so you will place here C as here 4, so 4 4 8. Okay, so you are getting now 16 8 8. Now again 8 8 and 8, so it will be on this B 8. Now 16 and 16 is here, that is A, so you are going to get here 32. So they are using A as 0, left hand side as 0, because A they are using 0. See, by using first option only you can eliminate. See, left hand side you are using 0, right hand side you are using 1. A is your 0, B is your 1 0, C is your 1 1 0, D is your 1 1 1 0, E is your 1 1 1 1 0, and F is your 5. Okay. So Bhaskar, one thing that you have did, so your code is also correct. You have chosen F here, but in the option they have chosen F in the right hand side, F on the right hand side. So you can choose F on the right hand side. Okay. See, you know that for a file you can have more than one encoding, for more than one encoding. Okay. हाँ, डिफरेंट कोड तो आ सकता है, ये डिपेंड करता है कि आप कोड कैसे बनाए, तो आपको ऑप्शंस देख के करना है। सो इन दी देखिए ऑप्शन में आपको क्या किया, देखिए पहला बीट आपको 0 लिया है, ए का तो आपको पता है कि ए का ज्यादा फ्रीक्वेंसी तो कम होना है, आप कुछ भी यूज करो आपको देख के ये समझना होगा कि ए को आप 0 या 1 लेंगे, तो ऑप्शन में ए को 0 लिया तो आप 0 लीजिए लेफ्ट हैंड साइड में। ऑप्शन देख के आपको डिसाइड करना है ना। ऑप्शन ए में देखिए, इन दी ऑप्शन दे हैव गिवन ए एज 0, ए एज 0, so by seeing the option you should decide that whether on the left hand side you should use 0 or 1. Am I clear? Clear hai Himanshu? In the option they are using A as 0, because it should not be 2 bit, it should not be 3 bit, it should be only 1 bit, it should be only 1 bit, either 0 or 1, and in the option they are using 0, so that's why I am using on left hand side always 0. That's why always on the left hand side I am having 0 and right hand side having 1. Now another question they have asked, what is the average, what is the average, what is the average length, what is the average length of the correct answer, of the correct answer to question 1. Okay, so what is going to be the average length, average length per bit? So what is going to be the average length per bit? Average length, average length of bit, average length of bit per character is going to your weighted external path length, weighted external path length by total number of character, by total number of character, by total number of character. Okay, so weighted external path length here is going to be 0 into 16. So see, this way you are finding, you can even find 16 into 1, 8 number of is 8, number of frequency of B is 8 into 2, 4 into 3, 2 into bit here is your 4, then here 5, then here 5. Okay, so weighted external path length is going to your weighted external path length is going to your 16 plus 8 to 16 plus 12 plus 8 plus 5 plus 5. So is going to 6, 6, 12, 12 to 14, 14 and 8, 22, 22 or 10, 32. Then in hand 3, so 1, 2, 3, 4, 5, 6, 62. Am I correct? Yes, 62. Okay. हमने राइट ले ले लेके बनाए थे, कॉम्प्लीमेंट हो गया। अच्छा, नहीं आपको ऐसा आप राइट लेके बनाएंगे तो ठीक है, वो सही है, लेकिन आपको ऑप्शन देखना पड़ेगा, ऑप्शन देख के आपको चूज करना पड़ेगा हिमांशु, आपको ऑप्शन देख के चूज करना पड़ेगा। ऑप्शन अगर यहाँ पे जीरो ए को जीरो कर रहा है तब वैसे ही करेंगे, ठीक है, वो तो बोलता ही है कि एग्जाम में तो आपको पहले ही बताया गया है, मतलब हम भी आपको बताएं कि एक कोड का एक एक फाइल का एक से ज्यादा इनकोडिंग हो सकता है, तो आपको ऑप्शंस देखना है कि ऑप्शन में वो क्या यूज कर रहा है। तो यहाँ so here we got weighted external path length is your 62 and total number of character is your 32, that is going to your 1.9375. Okay, so this is one way of finding the weighted external path length. Another way is also there. Another way is also there whenever they are giving the probability. So they have given the probability of A is your 1 by 2. Now how much bit is required for A? 1 by 2. Another way of finding the weighted external means the average you have to find. Another method to find average character, average length of bit, average length of bit per character, average length of bit per character. Another way, okay, see, this is another way of finding average length of bit per character. Average length I am asking. So you know that for this bit is required 1 bit, and here you are having a probability of 1 by 2. So since it is having a probability of 1 by 2, you will write probability into the bit. Probability into the bit 1 by 2 into 1. Now probability of B is your here 1 by 4. 1 by 4 into 2. 1 by 4 into 2. Now probability of C is here. C is here 1 by 8. 1 by 8. And another probability is 1 by 6. Another probability is 1 by 32. Another probability is 1 by 32. Okay, so I have written now only so that it can save our time. So C probability is C probability is 1 by 8, then D 1 by 16, then E 1 by 32, F is 1 by 32. Now see the bit requirement. So C is having 3, 4, 5, 5. 3, 4, 5, 5. So 3, 4, 5, 5. Okay. 3, 4, 5, 5. Okay. See here. So 3, 4, 5. Yeah, I have written correctly. So it's going to be 1 by 2. It's going to be 2 by 4. You can write as 1 by 2 only. 1 by 2, or you can take the LCM. You can take the LCM here. If you take the LCM, you are going to get. So this is another way. Probability they have given you. You have to find the average bit. Average bit required per character. Since the probability of coming A is 1 by 2, B is 1 by 4, C is 1 by 8, D is 1 by 6, and the bit requirement is 1. And here bit requirement is 2. Bit requirement is 3. So you have did the multiplication. Average is going to your LCM is 32. Here 1 into 2 plus 3 plus 4 plus 5 plus 5. Okay. Okay. I did one mistake here. Sorry. So LCM, since I have taken the LCM, let me write step by step. It should be 1 by 2, then 2 by 4, then 3 by 8, then 6 by 4, then 5 by 32, then 5 by 32. Now take the LCM. Okay, now take the LCM 32. So it's going to your 16. Then because 2 divided by 32 is your 16. Now 4 is your how much? 8. 8 to 16. Then 4 into 3, 12. Then it's going to your now this now 4 here again is going to your 8, 8 6, how much? 8 6 48. Am I doing correct? So 16 16 12 should be 8. 6 by 1 by 6. 1 minute. Its probability is 1 by 16. 1 minute. Its probability is 1 by 16. Sorry, its probability is 1 by 16 into 4. It should be 4 by 16. It should be, so while writing I have did mistake. It should be 4 by 16. It should be 4 by 16. Okay, so then 2, then 8. It will be 8. Then it will be 8. Then 5. Then 5. Okay. Now do the sum. 32 you will get here. I have did it. Okay. You will get here 62 by 32. Okay. You can see here. See, it's going to 32. Then here 10. Then here it's 12. And then here 20. See here it's 2. Then 6. 62. 62 by 32. Same. We got same. 19375. 19375. Please let me know whether it is clear. Say another way to find the average length of bit per character. This is the way. If they have given you the probability, if they have given the probability, and with that you find how much bit that is required. So one, then for these two, then this. So in this way you can solve the problem quickly. You no need to do the all these things weighted. You need to find the weighted external find then total number of character. You just see the probability and how much bit it is required. How much bit it is required. Total probability, how much bit. Total probability, how much bit. Total probability, how much bit. Okay, like this you have did it, you got it 1.9375. Okay, now, so hope is it done, and is it clear? Is everyone with me? सबको क्लियर है ना? किसी को कहीं डाउट है तो बोलिएगा. Is it clear to all of you? निशु कह रहे हैं यस सर क्लियर. Anyone still? Madhura, is it clear to you? Bhaskar, Bhaskar is saying clear sir. Arpan is saying clear. Fine. Now we will see our last example. Then we are going to finish our Huffman coding. Last example we are going to see, and even Nishu has said done. Fine. Now last example. So I hope that when if will exam, if this kind of questions will come, then you will able to do it correctly. So you can write as a tips here, as a tips. If the two node have the same frequency. So in this way only student get confused. If the two node have same frequency, the two node have same frequency, and so, and if the two nodes have the same frequency, so any node can be on the left side or right side. So any node can be, so any node can be left or right. So any node can be left or right, but if we are putting, but if we are putting the or placing, but if we are placing the new node on the left hand side, but if we are placing the, but if we are placing the, but if we are placing the new node on left hand side, then we should always place, then we should always place new node on the left hand side, then we should always place, then we should always place new node new node on the left hand, side. Then we should always place the new node on the left hand. Okay, whenever it will have the same frequency, whenever it will, okay, whenever it will have have the the same frequency. Or if you are putting on the right hand side new node, then you should always place on the right hand side whenever it will have the same frequency. Okay, so now another example we are going to see, that is going to be our last example. And from December, 1st of December, And from 1st of December, we will have the class from 4 p.m. Okay. Again, we will resume our class from our same previous timing. From 4 p.m. I will take. Okay. And after the class, whenever you will have any doubt, you can ask. Okay. Any generic doubt, if you're having, you can ask. Now, another example. If a file is having A, E, I, O, U, S, T, and its frequency is 10, 15, 12, 3, 4, 13, and 1. Then we have to find all these three. So we will add. First, we are going to add. We are having here 10. So we'll add 1, 4. So first one is your T, E. Then you are having 0 as your 4. Sorry, 3. So you are going to get 4. Okay. So 1, 15, 12, then 4, then 13, then 4. So then 4 and 4. Now I'm adding the new node on the left hand side. I'm adding the new node. See, I'm having a habit of adding the new node on the left hand side. So U I'm going to add on the left hand side. These two are smallest. So U 4, it is your U. It is going to your U. And when you will add, you will get a 8. Okay. So now you are having 10, 15, 12, 13, 8. Now you will add 12, 8 and 10, 8 and 10. So 10 will be on the right hand side. So what is 10? 10 is your A. 10 is your A. Then you are going to get here 18, 18. So you are getting 15, 12, 13 and 18. Now you are having 12 and 13. 12 and 13, the two lists, 12 and 13. So 12 will be on the left hand side and 13 will be on the right hand side. So 12 is your I, and 13 is your S. So when you will add these two, you will get 25. So 3, 2 is your 5, 25. Now see it means that you are all. It doesn't mean that you are always going to get a tree. Sometimes you will get a forest. This is a forest. It is not connected. So a tree is always going to be connected. A tree is a graph which is always connected. It is a forest. It is one component. It is another component. So it is not always that you are going to get a tree. So you have to separately construct this. Now you are getting 15. So sorry, you are having 12 and 13 you have added. 12 and 13 you have added. So you are having 15 and 25. Now 18. Okay. So now you have to add least to 15 here and 18 is here. So 15 will be on the left hand side. 15 will be on the left hand side. Okay. 15 will be on the left hand side. E 15. Now when you will add these two, you are going to get here what you are going to get. So 8, 5 is your 13. In hand 1, 2 and 3, 33. Okay, 33 you are going to get. 8, 5 is your 8, 5 is your 13. Now you got 15 and so 15 and 18 you have added. Na? So 25 and you are remaining with 25 and 33. 25 and 33. So you are going to add 25 on the left hand side. So 25 will come here. 25 will come here. I will be here. Here 12. Here is 13. Now we'll add these two. And you are going to 358. Then 5. 58. We are going to get 58. Okay. So you are going to get 58. So you will take 0 on left hand side and 1 on right hand side. And 1 on right hand side. Okay. So you got the code. So for I you got as 00, I 00, ace is your 01, ace is your 01, then E is your 10, E is your 10, then u is your 1100, u is your 1100, then a is your triple one, a is your triple one, okay, then a is your triple one, then u I have given, okay, then t is your 11011010 that is your t, 11010, and o is going to your 11011, okay. So I think it is correct. Are you getting same? Yeah. Now we will find the weighted external path length. Weighted external path length. Weighted weighted external path length is also called as weighted external path length is also called as total number of bits required, total number of bits required for encoding, total number of bits required for encoding, okay. So for a you require 2 bit, and I for I you require 2 bit, and I you are having 12. Ace you require 2 bit, and total frequency of Ace is having 13. Total frequency of Ace is having 13. So 13 into 2, these two done. E require 2 bit. E frequency is having 15. U require 4 bit, and U is having how many 4 bit? A you require 3. A frequency is your 10, and T you require 5 bit, and T frequency is your 1, and O you require 5 bit, and O frequency is your 3. O frequency is your 3. Okay. Is it fine? Okay. Now you add, it's going to 24. Then, okay, so please verify this calculation. Okay. So it's going to your 3 to 6, 26, 30, 4 for 16, 30 plus 5 plus 15. So it's going to your 20. It's going to 20. It's going to these two if you'll add. So it's going to your 40. These two is going to your 50. 50. These two we have added. Now 50 and 40 is going to your 90. 90 plus 30 is your 120. 120 plus 26 is going to your 146. 146. Okay, Bhaskar. So it's going to your 146. Okay. So please verify whether my calculation is correct or not. Okay. So you can please verify whether it is correct or not, whether you are getting 146 or not. Yeah, correct. Nisu is also getting 146. So weighted external path length we got as 146. Now average bit required for that. Average. So this is important because in GATE exam they will ask this. Average bit per character. Average bit required per character. Average bit required. Average bit required per character. Okay, average bit required per character is going to your 146 weighted external path length by total number of characters. This is weighted external path length by total number of character. How many characters? How you will get this total number of character? So the root is going to give the total number of character you are having. The root in a tree, the root. So that is you are having a 58. 58. So if you will divide, how much you are going to get? So if we'll divide, so you can use scientific calculator also. Okay, you can use scientific calculator also. It will give a practice. It will give a practice. So 146 divide by 58, you are getting 2.517. Okay, so 2 up to 4 decimal points. I will try to give. You should also try to give up to 4 decimal point. Is it fine? 2.5172 is the weight. Correct. So your Huffman coding, that is even called as weighted external path length, that is even called as non-uniform encoding, unequal size encoding. You have seen that why it is called as unequal size encoding, weighted external path length. Okay, so we have completed our Hookman coding. Okay, that we have seen. It is even called as, why it is even called as unequal size encoding, because variable size encoding, different size encoding. Okay, so we have completed our Hookman coding. So in GATE exam, they will give you a file, and they will say you that in a file they are having this A B C D as a character and the frequency of that, and after encoding what you are what you are going to get. Okay, what you are going to get. Is it clear to all of you? Anyone is still having any doubt, then you can let me know. Okay, if anyone, so you can like this session and subscribe this channel and press the bell icon to get instant notification of free lectures of. Okay, you will get the instant notification of all the free lectures of our classes. And those who have not followed me in Unacademy, they can follow me. And today also at 11 p.m. I am having a class that is going to be TOC. There I am going to teach TOC in Hindi at 11 p.m. in YouTube only, in this channel only. So you can see the, when you will go in the playlist of mine here in Theory of Computation by Suraj Shaw. Yes sir, क्लियर तो है, ओपन कोडिंग से बेहतर नहीं कर सकते. यस, यस सर, क्लियर तो. Okay, so today also at 11 p.m. in YouTube, I'm going to take TUC in Hindi. So you should come. Okay, and those who have not followed me, they can follow me in on Academy, because I'm going to take some classes, free classes on Unacademy also. So that is going to be free classes. And we have seen the types of subscription. So those who are preparing for GATE 2021 and 2022, okay. So 2022 and 2023, they can take 1 year subscription. They can take 1 year subscription, and even you are going to get doubt clearing session. And for any queries, you can even watch the special classes, the free courses that is available on Unacademy. Yeah, welcome Nisu. नहीं अभी तो नहीं है, यही है भास्कर, यही है अभी. ठीक है, इससे बेटर तो अभी तक तो नहीं है. ठीक है, और हमारे कोर्स में तो नहीं है. हमारे कोर्स में जो है हम लोग वही पढ़ेंगे सिर्फ. ठीक है, तो प्लस इन प्लस यू आर गोइंग टू गेट ऑल दिस 4 बेनिफिट्स. इवन डाउट क्लियरिंग सेशन you are going to get interactive, India's best educator, you will get interactive live classes, structure course in PDF, live test and quizzes. And from December my class will be from 4 p.m. From 4 p.m. I'm going to again start the algorithm from 1st of December. It's going to be from 4 p.m. so that more student can come. Okay, so that's why I'm going to take from 4 p.m. only. Algorithm will start from 4 p.m. from 1st December. And in iconic subscription, so those who are preparing for GATE 2022 and 23, they can take this subscription for 1 year, because there you require all the content. Okay, and the price will be as it is. You use my code SPSYT to unlock these special classes. Now to watch these special classes, free classes from 1st December, you have to unlock it. Okay, means you have to use the code. So you can use the code SPSYT to get even 10% instant discount in any of the subscription that is available on Unacademy, even to watch the free classes, that is special classes on Unacademy. Okay, so bye everyone. You can like this session, subscribe this channel, and press the bell icon to get instant notification. And in the description, the profile, the channel link is, Telegram channel link is there. Okay, you can subscribe, and you can join the Telegram group that is given in the description. Those who have not joined yet. So bye everyone. If anyone having any generic doubt, if you are facing any difficulties in the preparation, you can ask me. Is anyone having any doubt? You can ask me anything you want to ask, anything you want to cover that I teach that subject also, or any suggestion you want to give how my lectures is going on. If you have any suggestion, feel free to tell me. Okay, I'm always ready to take any suggestion, any improvement, anything. Okay, so I'm closing the session. I think that no one is having any query. So bye everyone. We will meet today at 11 p.m. TUC in Hindi.